Good morning, everyone. I hope you're doing well. I miss seeing you guys in class, so I decided to make a video today. It'll have 3 different screens. There'll be one as my camera. One will be the IAR test. So I decided to make a video. This is an optional video. I know some people were not happy with their scores, realize it's just a practice test. It's not going towards your grade. But if you wanted me to go over those questions with you and you were confused about them, that's what I'm doing on this video. So let's grab a piece of paper. I'm going to work on Cami on the electronic piece of paper, and you can bring this up. If you need to pause it, bring this up. It's the IAR test. The link is on Google Classroom. So the first question, they gave you 4 numbers that you have to fill into this table. It says a partially filled input-output table is shown. Complete the table so that it represents a function. You're going to drag and drop each number from the list into the correct input-output box. So here's the deal. A function, the definition of a function is that every input has only one output. So if I were to put 1 here, 1 is an input and it's going to both 4 and 6. That doesn't satisfy the definition of a function because every input only goes to one output. Well, 1 is going to 2 outputs, 1 and 4. So that means 1's got to be in the output section. Same thing with 5. I can't put 5 in the input because now there's 2 inputs going to 2 different outputs. No, well, I'm sorry, 1 input of 5 going to 2 different outputs. So 5 has to be over here. I don't think it matters where you put 1 and 5 as long as you know and you understand the definition that you cannot have an input going to more than one output. And as for 10 and 8, I think they can go in either place, but those have to be on the input section. So I hope that that makes sense. I've actually tried to make an equation with a linear line or with a quadratic, and that's not what they're looking for. They're just seeing if you know the definition of a function. All right, next question. This one I'm going to write on this piece of paper. So let's see if I can remember it. 0.5 times, I think it's 5 minus 7x. Let me make sure I'm copying it down right. Equals 8 minus 4x minus 6 equals 8 minus 4x minus 6. So here we just distribute. So half of 5 is 2.5. Half of 7 is 3.5x equals, and I believe there was a parentheses here. So now we have to distribute that negative 8 minus 4x. And let me just make sure. Yep. Then we have plus 6. Nope, I wrote it down wrong. So this was actually addition in the first place, and when you distribute, you get minus 6. There we go. All right, so now combine these like terms. 8 minus 6 is 2. 2 minus 4x on the right side. And then on the left side, we have 2.5 minus 3.5x. So I'm going to add 4x. And when I do that, I get 2.5 plus a half x equals 2. So now to bring your constants to one side, I'm going to subtract 2.5, and I get a half times x equals negative 1/2. Divide by a half on both sides, x is equal to negative 1. So that is your answer for here. Just I'll have to bring out my keyboard, negative 1. All right, perfect. Next question. So for this one, I'm just going to zoom in. So from negative 7 to negative 3, it's going up. So it's increasing. They're just wondering about the x values. From when they're giving you the x values. If you look at x as negative 7 to negative 3, your y values are going up. They start at negative 5 and they get to negative 3. So they're increasing. Now, when the x values are negative 3 to negative 1, so that's this section, that's a nice linear steep climb. Again, the y values are increasing. Negative 3 to positive 4. So that's increasing. When x is in between negative 1 and 1, That's this part right here, that it's linear, but it's going down. It's a negative slope. Your y values are going from 4 to 2, so they are decreasing. From 1 to 3, when x is going from 1 to 3, that's this part. It's not exactly linear, but it's still, the y values are going from 2 to 5, they're increasing. And then 2 more sections. We have 3, when x is in between 3 and 5. So it's not linear, it drops down, it's decreasing. And then finally, between 5 and 7, the x values are not, or I'm sorry, the y values are not changing. It's just 1, 1, 1, 1. It's always 1 for the y value. So the graph is neither increasing nor decreasing. So that is the answers for this section. I hope that makes sense. Next question. Okay, this one's a tricky one. We have to figure out the best approximate to locate the square root of 14, and we're doing this without a calculator. So let me minimize my screen here if it's going to let me. Ooh, I need to do that. Okay, so when we minimize my screen, let's go back here so I can write on this paper. So I have the square root of 14. To figure this out without a calculator, let's think of perfect squares. We have the square root of 9, and we have the square root of 16. Well, the square root of 9 is 3, and the square root of 16 is 4, which means my answer is going to be in between 3 and 4. So the next thing I look at is, how far away is 9 from 14? So 9 to 14 are 5 units away. And over here, 14 to 16 is 2 units away. So what that tells me is that 14 is closer to 16. So if we were to divide 3 and 4 in half, we get 3.5 in the middle. It's going to be in between these two numbers because this number is smaller. 14 is closer to 16. All right, so let's go to our problem. We hit that and we think we're done, but no, then they give you this blown up number line between 3.5 and 4. So the first thing, because I made a mistake on this at first, the first thing you need to realize is where the tick marks are. So the tick marks go from 3.5 to 4, and realize there are 1, 2, 3, 4, 5, 6, 7, 8, 9 tick marks. So they've divided this into 10 sections. So right here is 3.6. This is 3.7. This is 3.8. This is 3.9. So when I was first doing this, I was thinking, oh, 3.7, 3.8. No. 3.7 is here. 3.8 is here. Now, when I think about this part, all right, I know that when we go back to this piece of paper, my thought process is, okay, if I have 2 out of 7, to try to really figure out where this number is, if these are 7, so if between 3 and 4 was broken up into 7 pieces, 1, 2, 3, 4, 5, 6, so that's, 1, 2, 3, 4, 5, it would be like right here, but that's not how it is, okay? So what I'm going to say though is this is pretty close to 4, so I'm going to guess that it's 3.8. And then from here, I'm going to do 3.8 times 3.8. And yes, you don't have a calculator. You're going to have to do this the old way. So 8 times 8 is 64. Carry the 6. 24 plus 6 is 30. Then we have 3 times 8, which is 24. Carry the 2. And then we have 3 times 3 is 9. Plus 2 is 11. So we add that up. And you have 2 numbers after the decimal, so you go in 2 spots. 3.8 squared is 14.44. Well, that's great. It's greater than 14. So now, in order to square another number, I'm going to choose 3.7. And I'm hoping 3.7 squared is going to be less than 14. Let's see. 7 times 7 is 49. 7 times 3 is 21, plus the 4 is 25. 3 times 7 is 21, carry the 2. 3 times 3 is 9, plus the 2 is 11. Add that up, and you have 2 numbers after the decimal. Bring that in 2, great. 3 and 7/10 squared is 13.69. So now you have to think of this in relationship to 14. So when I looked at this, I was like, oh, the distance away, this is 0.44 away, and the distance between here and here is 0.31. So 3.7 wins, yay, except for when you go back to this graph, 3.7 is right here. So we have 3.6, 3.7, and this is 3.8. And then I'm like, oh, what if 3.75 squared is actually closer to 14? So, and before I walk away from this problem, I get to do that one more time. 3.75 times 3.75. One last time. So we get 25 to 35 plus the 2 is 37, carry the 3. 5 times 3 is 15, plus the 3 is 18. Perfect. Now, 7. 7 times 5 is 35, carry the 3. 49 plus the 3, we get 52. 7 times 3 is 21, plus the 5 is 26. Then last one, 3s. 3 times 5 is 15, carry the 1. 21 plus the 1 is 22, carry the 2. 3 times 3 is 9, plus 2 is 11. So we have to add these all up. You're hearing my dogs arguing. We have one old one and one puppy in the background. So the puppy gets annoyed, or sorry, the older one gets annoyed. So then we have 11, 16, carry the 1, 8, 10, and oh, fantastic. When we add this up, this absolutely is closer to 14. We get 14.0625. So yes, that one took a lot of work, but the actual answer is 3.75. So we're going to put our answer there and call it a day for question 4. Okay, this one's a pretty easy one. Which equation has both 4 and -4 as possible values of y? Well, if you take y squared, that could be 4 times 4 is 16, or -4 times -4 is 16. So your answer to that one is C. For this one, this is a system. They already gave you that x is 10. So I'm going to write in here 10. So now we have to figure out what y is. Well, substitute 10 into x's spot. So on our page, we have 3x plus 5y equals 20. Let's make sure I wrote it down right. Yep. So if x is 10, we do 3 times 10 plus 5y equals 20. 5y is equal to, this is 30, so we're subtracting 30 from both sides. We get -10, y is equal to -2. So that's your answer here. We do -2. They don't like that. So I'll do keyboard -2. Okay. For these ones, linear versus nonlinear. If you have any exponent, it's nonlinear. If x is being brought to the power of anything besides 1, then it's nonlinear. So that's nonlinear, that one's nonlinear, that one's nonlinear. This one would still be linear because 7 times 4x, that's y equals 28x. Even though there's a multiplication sign, that's okay. This one is slope-intercept form. And then this one is also slope-intercept form. It's y equals 1/2 x. You don't have a y-intercept. All right, so moving on. For this one, they are both going to cross at the y-intercept of 2. They have different slopes, but they're crossing at 0, 2. They both start there, and then one goes up 2 and over 1, one goes up 6 and over 1. The only time they cross is at 0, 2. So because they only cross there, they only have one solution. Okay, 6 divided by 11. So this one, we just need to old-fashioned do some division. So 6 divided by 11. Well, 11 does not go into 6, so we put a 0 there. 11 does go into 60 5 times, and you get 55. When you subtract 60 minus 55, you get 5. So add a 0, bring it down. 11 goes into 50 4 times. 4 times 11 is 44. Subtract, bring down, or you get 6 and then bring down another 0. And I'm like, oh, I'm back to 60. So this should be a little bit of a red flag. 11 goes into 60 5 times. That's 55. Subtract. You get 4. Bring down a 0. 11 goes into, oops, I'm sorry, you get 5. 11 goes into 50 4 times. And again, it's just this ongoing cycle that's going to happen. So then you get 6 again, it'll be 60. So your answer is 0.54 repeating. So 0.54 hundredths repeating again and again. Okay, so when you come back to the IAR website, you select answer D, 54 hundredths repeating. Number 10, 7 line segments are shown on the coordinate plane. Which of these segments could be the image of segment AB after a sequence of reflection, rotation, and or translations? So I think the trickiest part on this question is the fact that you have to read the directions really carefully. They only talk about reflections, rotations, and translations. They do not mention dilation. So AB is 4 units long. Goes from X being 1 to X being 5. So you have to figure or come up with which segments are 4 units long, because you could manipulate these in any way. You can rotate them 90 degrees. You then slide them left, right, up, or down in order to get on top of any of the other segments. But since they don't let us do any dilation, we can't make the line shorter or smaller. So when you look at all of these segments, I would say all of them can work except for the ones that are not 4 segments long. So we have KJ is not 4 segments, EF is not, and ML is not. So if we go here and we highlight all of them, then get rid of the ones that are not 4 segments. So I said ML, EF, and KJ. So get rid of JK and EF. I think that's it. And those are your answers. So it would be A, C, and F. All right, number 11. All right, we have the photos loading. So you have 3 different quadrilaterals. They're all the actual same shapes, same size. They're all congruent. We just have to manipulate them and do a transformation for them to end up on top of each other. So the first one is, how can I get figure 1 onto figure 2? So when I look at this, figure 1 and 2, I say, hey, we can just maybe flip it over the x-axis and slide it is what I see. So if I look at -5, -8, or +8. So -5, +8. If we flip it over the x-axis, we stay at -5, but then we go to -8, which is down here. And then we move that 3 units to the right. So let's see if that's a possibility. Flip it over, reflect on the x-axis, yep, and then move it 3 units right, and that figure will end up on itself. Perfect. So 1 will go on to 2. For part B, figure 3 can also be created by transforming figure 1 with a sequence of 2 transformations. So we go from 1 to 3. Well, if I look at that, it obviously rotated. So what are my options for rotation? We have a 90 degrees there, and here we have 180 degrees. So if I were going to rotate this figure 180 degrees, let me bring this up. If I have a figure that looks like this, and if I rotate it 180 degrees, it's going to look like this. Okay, nope, I lied. It'll go like that. Okay, so that's great. When I look at that compared to number 3, I'm like, all right, if it rotates 180 degrees, then I'm going to have to rotate it again. That might not be the exact solution. Why don't we try to rotate it in here? They give us an option of rotating it 90 degrees clockwise. Well, let's see what happens there. If I do 90 degrees clockwise, it ends up looking like that. Okay, it's not really a pretty There we go. Can I get that figure to look like number 3? And I think I can, because this would be in quadrant 2, and when I reflect it in the x-axis, that looks pretty similar to 3. So before I put those answers in, I am going to check my coordinates. And we can always just work with one of them. Let's work with -5, 8. So if this is at -5, 8, if I rotate it 90 degrees, so xy, let's get rid of this from the last problem. If I rotate it 90 degrees, the rule is they switch spots, and if we're going clockwise, remember my rule, this one changes signs. So we'll have 8 comma -5, and that one goes positive. So now this would be at 8 and then +5. Let's look. Is that point? Well, I guess we can't really do much of that. Then, because there's no figure on there. If I reflect in the x-axis, the rule is x stays the same, y goes opposite. So then I would end up with 8 being the same, going to -5. All right, well, if I go over 8 and down 5, is this where that point would be? Let's check. We go 8, down 5. Oh, beautiful. So that would be, we're going to rotate 90 degrees clockwise and then reflect in the x-axis. All right, moving on. I know this is long. If you don't have to watch the whole thing, it's one of those, if you just wanted to go over it. The graph represents y as a function of x. Place one additional point on the coordinate plane so that the graph continues to represent y as a function of x. So a function is that every inputs are your x values, only goes to one output. Output are your y values. So this graph right here, the input of -4 goes to the output of 4. There's no other input of -4 going anywhere. All the inputs for -4 just go to 4. The input of -2 goes to 3. The input of -1 goes to -2. The input of 0 goes to 1. This passes, if you remember, the vertical line test. All right, so it's a function. You could put so many different answers here. For -5, that's an input that doesn't have any outputs. So we could put a point there. -5 would go to 1. Or we could put a point right there. -5 goes to 3. We could use the input of 5. I could put any dot on the input of 5. What you cannot do is you can't choose an input that already has an output. So I can't say, oh, right there, because the input of -2 would have 2 outputs. It would have 1 and 3. Doesn't make sense. So there's many different answers. I'm going to choose that one and move on. All right, question 13. Here, let's go back. So I have 3 to the -8 over 3 to the -4. The rule is you subtract the exponents. So -8 minus -4, well, that turns into addition. So we have 3 to the -4. So that's one of the answers. If you make this so that it doesn't have a negative exponent, it's 1 over 3 to the 4th. And when you look at the answers, 3 to the -4 and 1 over 3 to the 4th, those are your options. All right, we're almost there. So for this one, you just need to graph. It's a system. They want you to solve it by graphing. So the equation of line S, it has an y-intercept of -3 and a slope of 1/3. So we go up 1 over 3. That's your line S. Line T, we start at 5. That's your y-intercept. It has a -1 slope. So I put -1 over 1, down 1 to the right 1. Oops, there you go. That's that line. Where they cross is at point P. That's the solution. Make sure you're on top of it. And that's your answer. Almost there. Number 15. Okay, line of best fit. So we have to choose the line. A line of best fit is the line that goes through the points. You want to have close to the same amount of points on top of the line and on the bottom. And the line has to follow the I know that the points are not a straight line, so there's not a specific slope, but it wants to follow the average slope. So what I'm saying, like letter B, that does not follow, okay? It's that line would shoot way up and the points would be below it. All right. So none of these. So for letter D, that kind of follows the same slope as the points, but there's more points below it than above. B and C, they're not a great line going through the points. A is your best choice for line of best fit. You have several points on the line. You have 1, 2, 3 distinct points above it, 4 below it. That's your best line of best fit for those guys. All right, last question. We're almost there. So the body of a 154-pound person contains approximately 2 times 10 to the negative 1 milligrams of gold and 6 times 10 to the 1 first power milligrams of aluminum. Based on this information, the number of milligrams of aluminum in the body is how many times the number of milligrams of gold in the body? So we need to know gold. All right, so let's look at it this way. Gold is the smaller amount times what? So times, let's say, the number of times equals aluminum. Okay, so in order to get the amount that you need to multiply by the x alone, we are going to divide by the amount of gold. So x equals the amount of aluminum, which is 6 times 10 to the first power, over the amount of gold, which is 2 times 10 to the negative 1. And maybe just because scientific notation uses an x, maybe we'll write this as y, so it's not confusing, because otherwise 2 x's. All right, so here we can look at this as 6 divided by 2, which is 3, and 10 to the first power divided by 10 to the negative 1 power. So here you subtract. So we have 1 minus negative 1, which equals minus a negative goes to addition. We end up with 10 to the second power. So 3 times 10 second power. Well, if the decimal's here, if we multiply by 10 to the second power, we move it over 2 to the right. So now your answer is 300. All right. Let's enter in 300 and let's submit. And so when you submit it, here's the score. 17 out of 17. I know this was a long video. I hope it helped. If you had any questions on Park from yesterday, or I'm sorry, from Tuesday. So I will be posting other videos for both geometry and algebra and integrated for all 3 of them. Feel free to comment if you have a way to answer some of these questions. By all means, comment so everyone can see it and share your ideas. And I hope everyone's well. Take care. Bye.